Hello everyone. Today let's solve the problem and sorting. Right. So this was asked in Codeforces round 793 division 2. 793 division 2. Right. So you can just go through the question. It is easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Right. So what the question states here, just give me a second, 1 second. Yeah. So what the question states here, we are given a permutation P. We are given a permutation P, right? So P of integers from 0 to n minus 1. We are given a permutation P from 0 to n minus 1. From 0 to n minus 1. So we can sort it repeatedly swapping by any two indices I less than j. We can sort it any two integers by swapping I less than j such that p of I and p of j equals x, such that p of I and p of j equals x. So this one I'm speaking p of I, and so the question itself states that and sorting, right? So we are going with p of I and p of j. This is equal to x, this is equals x, means comparing the value, this has to be equal to x, double equals basically x. So our task is to find the minimum such integer x that still allows the array to be sorted using the allowed operations. So this is important. What we have to find? We have to find the maximum such integer x, sorry, not the minimum, maximum such integer x such that still allows the array to be sorted using the allowed operation. So we have to go with this thing, what do we call, either bitwise tree, or we can go with the bitwise manipulation, bitwise manipulation or bit manipulation as well. So we have to go with the and operation at any cost, right? So here also we can go with the sorting as well. We have to go with the sorting. So question itself says that and sorting, right? So we have to go with the bit manipulation, bitwise tree or bit manipulation here, right? So here uh, I'll just read out the question, just listen to the question. So here we have been given a permutation p of integers from 0 to n minus 1. This part I'm speaking of, we have given permutation p from 0 to n minus 1. We can sort it repeatedly swapping any two indices I less than j. We can swap it, we can swap we can sort it by repeatedly swapping any two indices I less than j such that p of I and p of j equals x, such that p of I and p of j equals x. Our task is to find the maximum such integer x that still allows the array to be sorted using the allowed operation. We have to find the maximum such integer x that still allows the array to be sorted using the allowed operation, right? I hope the question part is completely clear, man. Right? I hope the question part is completely clear. So here p is nothing but the permutation from 0 to n minus 1, and we will be given x as well. We will be given x as well in the input. I hope the question part is completely clear. Let's come to the input output part, or the example part here. So we have been given four inputs. The first line states that we have given we have been given four inputs. One is this one, this part, 40132. Next 210. So 7 this one. Yeah, 7 this part, and the last part is this one, 503214. Means here the first input consists of 40132. So let's consider this one, man. Let's consider everything. Let's not discuss the approach now itself. So here we have this one, 40132. We need to get the output 2. We need to get the output 2. Here I just want to tell you one thing. This 4 is nothing but n. This 4 is nothing but n here, right? So this 4 is nothing but n. So we have been given permutation p of integers from 0 to n minus 1, right? So here we have been given n equals 4, means 4 integers. It has to consider, we have to consider 4 integers. See, in the next line we have 4 integers. This is nothing but p, permutation p, right? So we have 4 integers, n is 4, right? So we have to have the 4 numbers or the integers here. So next we have 2. So we have p, which consists of the two integers. One is 1 and 0. It same goes with 7 here. We have 7 integers. You can clearly see here 5 integers. This is first line, whatever the number. In our case, the first input if I take, we have been given 0, 1, 3, 2. 0, 1, 3, 2. 4 is nothing but n. 4 is nothing but n. This is nothing but p. Array. We can consider this one within the array. This is nothing but p, 0, 1, 3, 2. So this one I'm speaking of, right? So we need to get the output 2041. Means the maximum such integer x that allows the array to be sorted using the allowed operation is 2. For the first input it is 2, for the second input it is 0, for the third 4, and for the 1. So I hope the input output part in the question part is completely clear. Let's discuss the approach followed by the complexities, and then let's write the code. So I'll just consider this first example for the approach. So I insist you to try out with the second, third one, or the fourth one in the similar way that I show you, right? So let's consider the first example. I'll be considering the first example or the first input here. So the output that we need to get here is 2 for this one, right? Also, let's discuss the this one. What is the data structure we'll be making use of? What is the data structure we'll be making use of? So what approach we'll be going with? So these kind of things we will be discussing in the approach. First, let's discuss the approach. So here I have considered the first example, the same example that they have given in the question, the first input, right? So here we have 4, n equals, we have 4, and this one p equals 0, 1, 3 to the output that we need to get here as 2, right? So we will be making use of the bit manipulation or the bitwise tree approach, right, to solve this particular problem. We'll be making use of the bitwise manipulation or bitwise tree to solve this particular problem, right? So let's go with the step-by-step explanation here. So n we have been given for p we have 0, 1, 3, 2. First, what we will do, we will sort this. We will sort the permutation of the numbers that we have been given 0, 1, 3, 2, right? So when we sort this one in the ascending order, we will get 0, 1, 2, 3. So we will get 0, 1, 2, 3. This first we will sort this. We get 0, 1, 2, 3. So then we will identify the mismatches. Here, when I say we identify the mismatches, so we have the mismatch, this one for the position 2 and 3. For the position 2 and 3, this and this one, these two I'm speaking of. We have the mismatch 2 and 3 for the positions 2 and 3. Means 3 is not equal to 2 and 2 is not equal to 3. 3 is not equal to 2. 2 is not equal to 3. Right? So here in this case, um, let's let me come here. So here, for all the mismatched positions we compute the bitwise AND. We will be going with the bitwise AND of p of I and the sorted I, of p of I and the sorted I. For the sorted I we have 2 and 3. In the position 2 we have the value 2, in the position 3 we have the value 3, and what is the mismatched positions? Basically 3 and 2. So 3 and 2, this one we are considering, right? 3 and 2 for the position, this one 3 and 2. So we will be going with 3 and 2. This is nothing but we are computing by making use of the bitwise AND. So this is nothing but bitwise AND. So just give me a second. What happened to this one? 1 second. Just give me a second. So yeah, we will be making use of the bitwise AND here. Bitwise AND, right? So here in this case, we will be going with a 3 and 2. So here, we will be going with the 3 and 2 and 2 and 3, right? So here, when we convert 3 to binary, this is 3. When we convert 2 to binary, this is 2. So same goes with this one. So any two you can consider, either this 2 is also same for this one. Basically, this 3 is also here, this one 3 itself. So 3 and 2. So this is nothing but 3, this is nothing but 2. And second one, this is nothing but 2, this is nothing but 3, right? So we are going with a logical and bitwise AND operator, right? So here this one, when both are 1, when both are 1, then only it is 1. When both are 1, then only it is 1 or true, right? Otherwise, all the operation is 0. All the operations are 0. Basically 0. So we'll go with the right set first. 1 0 will lead to 0. Here we have 1 for both. So 1. All others are 0. All others are 0 itself, right? So this is nothing but 2. This is nothing but when we convert this one, we will get the when we convert this one to number, we will get 2, right? So here also same thing, right? So we will get 0, 1. So this is 0 itself, right? Same thing, 2 we get, right? That is how we got 2 here. That is how we got 2 here, right? So we are just converting this one to the binary. We are just converting this one to the binary, and we are performing bitwise AND operation, right? we are performing bitwise AND operation. Now that is how we got the answer 2 for both. That is how we got the answer 2 for both here, right? So the maximum x must be the bitwise AND of all the mismatched pairs, right? So the maximum x must be the bitwise AND of all the mismatched pairs, right? And so final answer is here 2. The final answer that we got here is 2, right? So the maximum x must be the bitwise AND of all the mismatched pairs here. So the final answer that we got here is 2. So the answer that we got here is 2, which is equivalent to the output that they have mentioned for the example 1, which is equivalent to the output that they have mentioned for the example 1, right? So here in this case, yeah, our approach works absolutely correct in this case, right? Our approach works absolutely correct in this case. So basically, we went with the bit manipulation or bitwise tree approach, right? So as we are done with the approach, or familiar with the approach, it's good that we move forward with the complexities part, right? So what is the overall time complexity here? The time complexity would be big of n log n. The time complexity would be big of n log n because we will be going with the sorting. The first step itself here in the approach is sorting. So here let me show this one again. See here the sorted version. So it was 0 1 3 2. Basically after sorting in the ascending order we got 0 1 2 3. The first step itself was basically sorting, right? So sorting, whenever we make use of the sorting, sorting becomes the dominant factor, man, right? So whenever we make use of the sorting, sorting becomes the dominant factor. Overall time complexity would lead to big of n log n, big of n log n, right? So what would be the space complexity here? The space complexity would be big of n because we will be going with the copying array using the temporary arrays. So we will be going with the copying array and we will be making use of the temp arrays. So the overall space complexity would lead to big of n. This you will come to know when we write the code, man. So don't stress much on the space complexity part. So the time complexity is due to the this one sorting, right? Accordingly with the approach we are going with the time complexity, right? So the time complexity would be big of n log n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n log n and big of n. So as we are completely done with the complexities part, as well as the approach part, we are good to write the code. Let's start writing the code. So now let's start writing the code, right? So we will be making use of the different utilities. So I'll just go with the utility package. So I'll just go with import java.util.star. So this is fine. The next thing is I'll just go with the class name main. So I'll just go with public class main. So this is fine. Next, we will be making use of the helper method or the helper function to get the maximum value of x. We have to get the maximum value of x, right? Such that permutation is sortable, x sortable basically in simple terms, right? So I'll just go with static. So this one is static int get max sortable. So you can give any name. I found this one relevant, so I gave you a sortable. So this one x, right? So this is fine. So I'll just go with int p. So the parameter p and n. The parameter p and n. So p is nothing but the permutation array we have considered. N is nothing but the number of elements, right? So here in this case we have to, first thing is we have to clone the original. We have to clone the original to create a sorted reference, right? First we have to get the original array, means clone the original, and we have to get the sorted reference first. We have to get the sorted reference and then we can sort it and then we can sort the array, right? So first let's clone the original. So I'll just write here int sorted equals, so this one would be p dot clone, p dot clone. This is fine. So the next thing here would be arrays dot sort of this one will be sorted. This is fine. So next let's start with all the bit set. Let's start with all bits set, like 1 1 1. So we have to go with like that, right? So I'll just go with int x equals negation of 0. So this is fine. So next part, let's go with the iteration, man. We have to do for all the numbers the same. So I'll just go with int I equals 0, I less than n. Let me go with I plus plus here. So let me write the simple if condition here, because we have to consider only the mismatched positions. We have to consider only the mismatched positions, right? So we in simple terms, we have to go with the bitwise AND operator, right? Or this one AND operator, right? So first we have to convert that one to the binary, and we have to perform the AND operation accordingly with the approach. If you remember, right? So that's what we need to do. That's what the same thing we are articulating in the form of code here. So this will be if p of I is not equal to sorted of I, this one I'll just go with x and equals p of I and sorted of this is fine. We are just updating the x and ending with the each pair. So I'll just come out of this one entirely. So I'll just go with return x. I'll just go with return x. So this is fine. This is fine. We are done with this one. Return x because we have to return the final result, right? That is that is nothing but the maximum x that allows the swaps among the mismatched. So that is the reason I have returned x. So this is fine. So let's make use of this one. What do we call? Um, what name I have kept here? Get max sortable x, right? So here we do one thing. Yeah, let's make use of a ton. This thing, the main function here. Main function mostly consists of the input output part, man. We just have to print the maximum sortable x of p comma n. P comma n parameters p and parameter n. So that is where we'll be making use of the helper method. That's it. So this main function mostly consists of this one. What do we call? Input output part. So I'll just give me a second here. So I don't have to make use of throw input output exception. I think this is fine. Let's write the code first. So let's go with the scanner for reading the input. So this one will be sc new scanner of this one will be system dot in. So this is fine. So the next step is we have to go with the number of test cases. So I'll just go with int equals scanner dot I'll just go with next int here. So we are not making use of this thing, right? Buffered input and the print writer. Buffered reader and the print writer, sorry. We are not going with the fast input output operation. Scanner is enough, man, for this problem, basically. So here, we have to go with the first. So we have to go with the test cases as well, right? So I'll just go with the while loop here. Just type this one as it is input output part. So I'll just let's go with the length of the permutation, nothing but here n equals scanner dot. So this will be next int. This is fine. And also we have to go with the input permutation. So I can just write in this way, p equals new int of n. So this is fine. So the next step, let's go with the iteration part. For int I equals 0, I less than n, let me increment the I. So within the for loop, we have to read the values into p, nothing but iterated value of the p equals scanner dot again next int, right? Next int. So this part is fine. Finally, we'll be making use of this one, get max sortable x helper function or the helper method here. So we have to print the get max sortable x of the parameters p and n, basically, right? So for that I can write on this way. I'll just go with the println system out println. So this will be get max sortable x of p comma and parameters I'm speaking of, right? So I hope this part is completely clear, man. So this is it for the code. So this is it for the code. Before checking the code with the different inputs, so I just want to copy paste the signature starter template, right? So just give me a second here. So let me come here. Let me paste it over here. So let's concentrate on the logical part. So I'll just come here. Yeah, let me copy this input. Let me copy this input. The output that we need to get here is 2041, right? So let me paste it over here. Let me run this code. So yeah, we are getting the output 2041. Means whatever the code that we have written works absolutely correct for the examples that they have given in the question, right? So let's check whether this works for all the test cases or not. So I'll just come here. Let me select B. This is B, question B, right? So yeah, let me paste it over here and let me hit the submit button. I hope this works for all the test cases, man. Let's wait for some time. Can clearly see here running on test one. So yeah, you can clearly see here we have got the verdict accepted, right? So the code got accepted here. Means whatever the code that we wrote works absolutely correct for all the test cases, right? So we went with simple bitwise tree approach. We went with simple bitwise tree or bit manipulation approach. We went with the AND operation, right? Basically, to be frank, and also the sorting. We went with sorting along with the bitwise bit manipulation, we can call, or bitwise manipulation. Both are correct, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.